Hi guys, so today we're going to talk about something called pH. pH is something that, a lot of people have heard ever since middle school or something like that, but most people don't know how to actually calculate pH and what pH really means. So we're going to talk a little bit about that today. Oops, I went a bit too far there. As most of us know, the pH scale goes from 0 to 14, right? We know that 7 is neutral. If you're under 7, you're an acid. If you're above 7, you're a base. But what does this scale actually mean? Okay, so if we talk about a sample of pure water, okay, you are going to have a little bit of hydronium in there and a little bit of hydroxide. Remember, when two water molecules collide, one transfers the hydrogen to the other. So we get hydronium and hydroxide, but only a little bit, okay? And actually, the concentration of hydronium and hydroxide are exactly the same at 1 times 10 to the negative 7 molar, okay? So moles per liter. So what that means is that we have this much of hydronium and this much of hydroxide, even in a pure sample of water, okay? So this number 7 here actually comes from this exponent, okay? Now, what we do here, okay, the actual formula for pH is negative log, and it's a log base 10, for those of you who learned about log, the concentration of hydronium. Or you can even say just the concentration of the hydrogen plus ion, okay? Now, for those of you who have taken Algebra 2 or are taking Algebra 2 and you see log, you're like, oh my gosh. Or if you've never taken Algebra 2, you're like, I have no idea what it's talking about. Basically, log base 10, we're talking about powers of 10. Okay, so I'm going to make it real simple for you. So these numbers here, 1, 2, 3, 4, 5, 6, are based on the exponent of the scientific notation. So a difference between 6 and 7 is not a difference of 1, it's a difference of a power of 10. A difference between 5 and 7 is not a difference of 1. It's a difference of 10 times 10, so it's a difference of 100. So a pH 5 is 100 times more acidic than a pH of 7. A pH of 1 is going to be 10, 100, 1,000, 10,000, 100,000, 1,000,000 times more acidic than a pH of 7. Okay, so the scale is just based on the powers of 10, and that's all you got to do. And honestly, to calculate pH, you just need to know where the equals button is on the calculator, the negative button. There's a log button in your calculator. Parentheses, type in the number, close parentheses. Okay? So even if you haven't taken Algebra 2, you can do a pH calculation. It's that simple. And this scale here is based on the power of 10. The distance, each number is times 10, whether you're going to the left or to the right. Okay? That's all that it means. All right? So this is our main formula right here, pH. Okay? The P is for potential of hydrogen, but it's the same thing as the negative log base 10. Okay? Now, we don't have to calculate just the pH. We actually can calculate the pOH. Okay? And pH plus pOH always equals 14, because our scale goes up to 14, right? These here are opposites of each other. Okay? So if I have the concentration of hydronium and I want to calculate the pH, I use this. But if I have the pH and I want to calculate the concentration of hydronium, I use this. Okay, so if the opposite of this reaction is 10 to the negative pH, gives me the concentration of hydronium. And same thing over here. Okay, so for the next few problems that we're going to do together here, we are just going to use these equations over and over again. Okay, to calculate the problems, and it's actually really simple. So I'm going to do, I think, 5 problems with you guys, so you can kind of get a feel for it and feel comfortable for it, and then we'll be done. Okay, so if you need to write these equations somewhere so you can refer to them as we go through, please feel free to do so. All right, so let's work through our first problem over here. So pH of 0.12 mol. What is the pH of a 0.12 molar solution of hydrochloric acid? Okay, so I'm only going to have you guys calculate the pH of strong acids and strong bases. Weak acids and weak bases require a lot more work. So we are just going, because these strong acids and bases dissociate completely, we are just going to take this concentration here as the concentration of your hydrogen ions. Okay, so basically pH is the negative log of the concentration of my hydronium or my hydrogen ions. So it's going to be negative log of 0.12. Okay, and if you don't have a calculator near you and you have your phone or something like that, go to Google, literally type this portion right here, and you will get the answer, which is 0.92. It's that simple. Okay, this is your pH, 0.92. So very acidic. Now, hydrochloric acid is your stomach acid, okay? And here's your stomach acid has a pH of approximately 2. So I know my pH is 2. What is the concentration of the hydronium ions? Okay, so I'm looking for my concentration of hydronium ions. Remember, those brackets mean molarity or concentration. I know that my hydronium ions are going to equal 10 to the negative pH. Okay, so I'm going to make that equal 10 to the negative 2 because my pH is 2. Well, 10 to the negative 2 is the same thing as 0.01 molar. So that is the concentration of hydronium ions in my stomach. What is the concentration of hydroxide ions in my stomach? Well, I know that hydroxide, the concentration of hydroxide, is going to equal 10 to the negative pOH because I have that equation. Well, I know that my pOH is 12 from the previous problem, so 10 to the negative 12 is my concentration of hydroxide ions. So this is the same thing as 1.0 times 10 to the negative 12 molar. That's my concentration of hydroxide ions. Okay? One last problem. This is actually a typo here. It should be 0.12. What is the pH of a 1.2 molar solution of sodium hydroxide? Okay, now this is a little bit trickier because I'm going to need to use two equations. Because this is sodium hydroxide and it has hydroxide in the equation, not H+, I can't find the pH right away. I can find the pOH. Okay, so let's start with that. pOH is going to be the negative log of 0.12, which is 0.92. Okay, well, now I know my pOH. Is there a way in those equations to find the pH? There are different ways that you could use. The easiest one is just knowing that pH plus pOH equals 14. So if my pH plus 0.92 equals 14, I know that my pH is 13.08. And it's as simple as that.